In this lesson, we're going to talk about multiplying radical expressions. So in the previous lesson, we talked about adding and subtracting radical expressions and how the only way we could add and subtract radical expressions would be if the radicands, the number underneath the radical, were the same. When we multiply radical expressions, we don't necessarily have to worry about that. Okay, the rule of thumb is going to be this. You're going to multiply the like pieces. All right, so what I mean by that, and I'll try to color code this here for you, we can multiply the numbers out front. All right, and then we can also multiply the numbers underneath. And so if we start by multiplying the numbers out front, 3 times 5 would give us 15. And 6 times 2, that gives us the square root of 12. So we keep the numbers that were underneath the radical underneath still. Okay, we should always completely simplify at the end. Okay, so we should break up 12 into the square root of 4. So because 12 can be written as 4 times 3, where 4 is a perfect square. We know the square root of 4 is 2, so it's 15 times 2 times radical 3, or 30. Radical 3 would be completely simplified. You don't necessarily have to simplify if you could, which we could not in this case. In the beginning, you could simplify and wait to the end. Perform the operations and then simplify at the end if you can. In example 2, we're going to use something called double distribution. Double distribution just means this, is that each piece is that going to multiply to each piece in each binomial. So the 3 radical 2 multiplies to both of them in the other binomial, and then the negative 2 radical 5 multiplies to both of them in the other radical. I'm going to show you a way right now to organize this. You also may have heard this term called FOIL. FOIL just stands for first, outer, inner, and last. I may have spelled outer wrong there. I think there's one T in there. Okay, so all that is, it's just a way for us to remember which ones to multiply. The first ones in each set of parentheses, the outer one, so the 3 radical 2 and the radical 8, the inner ones, the opposite, and then the last ones in each. That helps us just to know that we have to multiply everything. But overall, what we're going to look at is that in the box here, this is just going to organize our multiplication of 3 radical 2. And then we have minus 2 radical 5. I'm going to put the negative with that. And we're going to multiply by 4 radical 20 and radical 8. And what we're going to do is multiply each column and row together. So we'll start with a 3 radical 2 and the 4 radical 20. Remember, we multiply the like pieces, so 3 times 4 is 12. Radical 20 times radical 2 is radical 40. Then I'll move on to the right here. 4 times negative 2 is negative 8. Radical 20 times radical 5 will be radical 100. 3 radical 2 times radical 8. Technically, remember, there's a 1 out front here, so this would be 3 radical 16. And then finally, this would be negative 2 radical 40. So I'm going to take this out of the box. Any positive term is really going to be, if you wanted to, you could write a plus to represent positive. But what we get is 12 radical 40 from the top left, minus 8 radical 100, plus 3 radical 16, minus 2 radical 40. And we can do a few things here. One thing we can do is combine the like terms here, and we can subtract 12 radical 40 minus 2 radical 40 since they have the same radical. That would come out to be 10 radical 40s. Minus 8, we know radical 100, or the square root of 100, is 10, so minus 8 times 10, plus 3 times the square root of 16 is 4. So in the same step, so we don't have to write a million steps here, okay, we can break up the square root of 40 into the square root of 4, square root of 10. Minus 8 times 10 is 80, plus 3 times 4 is 12. Okay, that's a 2 here. Yep. We know the square root of 4, and just for the sake of space here, the square root of 4, I'm just going to say we know that's 2, right? So it's 2 times 10 really out front there. So this is 20 radical 10. We can combine minus 80 plus 12 into minus 68. and that's as far as we can go, and that would be our double distribution here. All right, let's do a few of these, and then we'll state whether they're rational or irrational. Remember, a review from our first lesson in this unit was that any radical expression will be rational if we can simplify and get rid of the radical. If we can simplify completely and cannot get rid of the radical, then it would be irrational. So in 1 here, since we have no coefficients, no numbers outside of the radical, we just multiply what's underneath, and we get the square root of 28. We can simplify this. This can go to the square root of 4 times the square root of 7, which the square root of 4, hopefully by now, we know is 2. Square root of 7 would be completely simplified. Since we still have a radical, this would be irrational. Okay. Let's take a look at 2. We can multiply the 2/3 times the 9. You can put this in your calculator or think this is 9 times 2 is 18. Divided by 3 will give us 6. Square root of 72. So the question becomes, what's a perfect square that goes into 72? All right, you should start with the larger numbers and work your way down because we want to find the largest perfect square that does this. All right, but the answer is going to be 36 times 2 is 72. So we can say this is 6. Square root of 36 times the square root of 2. Square root of 36 is 6, so this becomes 6 times 6. Square root of 2, which just ends as 36 square root of 2 as our final answer, completely simplified. And it's irrational because we have a radical left over. Let's take a look at 4. Remember what a squared means, right? An exponent means here that you have 3 radical 6 multiplied by 3 radical 6. Okay? We could use an exponent rule, but it would be way easier for us to just rewrite it. So rewrite it knowing that this exponent here means both of these are being multiplied together. And then we can just use our multiplication rule that 3 times 3 is 9. Radical 6 times radical 6 is radical 36. Okay, well, 9 times 6 would give us our final answer here because the square root of 36 is 6, and then we will get 54. There's no more radicals, so this is a rational number. I'm just going to do a little side note here. So when we're multiplying radicals, if you multiply 2 radicals that are the same, right, we have, for example, we just had radical 6 times radical 6 was radical 36, which we could just say is 6. I'm going to give you another few examples. Radical 3 times radical 3 is equal to radical 9, which is just 3. And also, let's do radical 7 times radical 7 is radical 49, which is 7. I'm hoping what you're noticing here is that our rule of thumb is that, look, whatever's underneath our radical, if we multiply a radical times a radical and they have the same number underneath, that's just going to be our answer without the radical. So 3 and 3 were our radicands. 3 is our answer. 7 and 7 were our radicands. 7's our answer. And the whole reasoning behind this comes from our exponent rules, in that what we just did was if we can rewrite radical 6 times radical 6 as radical 6 squared. Same thing, radical 3 squared here, and radical 7 squared. And essentially, just like addition and subtraction are to one another, or multiplication and division are to one another, squaring and the square root are opposite operations. So taking the square of something, then squaring it, would be like adding something, then subtracting it. It does nothing, right? If I add 3 and subtract 3, you end up with nothing, right? Or you end up with your original. If you have $10, you added $3, then you spent $3, you end back with $10. So in this case, if you square root 6 and then square 6, you end up with 6, right? So the rule of thumb, just that you need to know, if you multiply a radical times the exact same radical, it just turns out to be the number that's underneath. Let's take a look at 6. This is some distribution here. Radical 6 is going to multiply to radical 3 and to negative 2 radical 6. Radical 6 times radical 3, we can multiply what's underneath as radical 18 minus 2. And then we can write this if you want. Radical 6 times radical 6 is radical 36, but we just talked about this rule because of the fact that the radicals are the same, this is just going to turn out to be 6. But you could have written this as radical 6 times radical 6 is radical 36, and then eventually simplified. We can simplify the square root of 18. 9 is a perfect square that goes into 18, so we have 9 and 2. Minus 2 times 6 is 12. One more step, square root of 9 is 3, so this is 3 radical 2 minus 12. Completely simplified, can't go any further. Since it still has a radical, this would be irrational. We'll do a few more. Let's look at 8. Same idea, radical 2 is going to be multiplied in. All right, remember there is technically a 1 here if nothing's shown as a coefficient out front. So 3 times 1 is 3 times radical 14 plus 2 times 1 is 2 times radical 10. 14 only has factors of 2 and 7. Neither of those are perfect squares, so that's completely simplified. Radical 10, its only factors are 5 and 2. Neither of those are perfect squares, so this is completely simplified. Radicals left over makes it irrational. We're going to do 9, 10, and 12, and then we'll be done. So for 9, we have this double distribution. We know when to use double distribution because of the fact that we have 2 terms. It's a binomial times a binomial. So what I'm going to suggest, and you do not have to necessarily do this, if you want to just distribute both the terms that are in the first binomial. But what I'm going to suggest is using that box method just to organize some things. So we have 2 minus 4 radical 2, and then we're being multiplied by 2 plus 4 radical 2. And we multiply rows and columns. 2 times 2 is 4, nice and easy. Negative 4 radical 2 times 2 will give us negative 8, and there's no other radical, so radical 2 just comes along. 2 times 4 radical 2 is positive 8 radical 2. Negative 4 times 4 will give us negative 16. Radical 2 times radical 2, remember we could write it as radical 4, but we know the square root of 4 is 2. Right? Remember, if you multiply 2 of the same radicals together, it's just going to come out to be 2. So this is going to be negative 16 times 2 down there. If we write this out, we get 4 minus 8 radical 2 plus 8 radical 2 minus 16 times 2. We can simplify here to 32. You might notice what's going to happen. Okay? Negative 8 radical 2 and positive 8 radical 2, when we add them together, since the radicals are the same, that would be 0 radical 2's or just 0. They cancel out. And we can do 4 minus 32 as well. That will give us negative 28. The radicals dropped, so this is becoming rational. 10 is very similar. Okay, remember, whenever you see the squared, write it out. This will be radical 3 plus radical 6 times radical 3 plus radical 6, because the squared indicates we are multiplying it twice. I'm going to use this organization again, where we have 3 plus radical 6 and 3 plus radical 6. 3 times 3 will give us 9. 3 times radical 6, they have no like pieces, so we just leave it as 3 times radical 6, or 3 radical 6. Happens again in the bottom left. And radical 6 times radical 6 just simplifies to give us 6. So what comes out of the box is 9 plus 3 radical 6 plus 3 radical 6 plus 6. So all the terms are positive. That's why we're saying plus. Okay? And we can combine the like terms. 9 and 6, we can combine to 15. Plus, there are 3 radical 6's plus another 3 radical 6's. Since we're adding, we just add the numbers out front and say that this is 6 radical 6's. You should think, can we simplify 6? The answer is no. We still have a radical, which would make this irrational. Okay, one more. We're going to look at 12. We'll distribute 12. So 3 radical 2 goes into both of these. Remember, there's no coefficient out front of the radical 8 and radical 24, so we assume it's 1. So we get 3 radical 16 plus 3 radical 48. Okay, and we can simplify radical 16. That's just 4. It's 3 times 4 plus 3 times the largest perfect square that goes into 48 is 16. So this is 16 and 3. So this is, well, we can do 3 times 4. Simplify that here. 12 plus 3 times 4, radical 3, or 12 plus 12 radical 3. We can't add these together because the first term doesn't have a radical 3. That would be our final answer. There's still a radical, which would make this irrational.